Imagine a world where the warmth of the Gulf Stream is a thing of the past, and the climate in northern Europe has plummeted by as much as 15 degrees Celsius. Sounds like a scene from a dystopian novel, right? But here's the thing. It's not just fiction. Scientists have long warned that a slowdown of the Atlantic Meridional Overturning Circulation, AMOC, a vital system of ocean currents, could have catastrophic consequences for our climate. And now, a remarkable discovery in a Bermuda cave has shed new light on the AMOC's past, and what it might do as the climate changes further. Deep beneath the subtropical paradise of Bermuda lies a vast network of caves, containing records of Earth's climate history that date back centuries. Inside these caves, towering stalagmites have grown slowly over the years, their chemical composition influenced by the drip water that formed them. By analyzing the chemistry of one of these stalagmites, researchers have been able to reconstruct past sea surface temperatures with remarkable accuracy. The latest research, published in the journal Communications Earth Environment, harnesses this information to create a long-term picture of Atlantic Ocean temperatures, with a data point every 10 days stretching back to the year 1449. This record reveals a startling shift in the Gulf Stream, a major ocean current that plays a crucial role in keeping Western Europe mild. Around 300 years ago, the Gulf Stream began to move northward, a sign that the AMOC was starting to weaken. But what exactly is the AMOC, and why is it so important? The AMOC is a vital system of ocean currents that helps regulate our climate. It works like a conveyor belt, moving warm surface water from the Gulf of Mexico northward across the Atlantic, where it cools and sinks, flowing back south at depth. This process helps distribute heat around the globe, keeping Western Europe relatively mild compared to other regions at similar latitudes. However, if the AMOC slows down too much, it could have disastrous consequences. Northern Europe would experience extreme cooling, while rainfall and weather patterns across the tropics and subtropics would shift and intensify. The impact on wildlife and food security would be severe, as ecosystems struggle to adapt to the changing climate. Now here's where it gets really interesting. Scientists agree that the AMOC is crucial for regulating our climate, but there's great uncertainty surrounding its stability. Some studies suggest that the AMOC has weakened in recent years, while others argue that there's been no significant change. But what if the AMOC has been weakening for centuries, long before the onset of wide-scale industrialization? That's exactly what the Bermuda Stalagmite suggests. The record shows that before the year 1720, ocean temperatures were unusually high, coinciding with the Little Ice Age, a cold interval in the northern hemisphere. But after 1720, sea surface temperatures in Bermuda cooled substantially, while records to the north show the opposite, warming where there had previously been cold temperatures. This shift suggests that the AMOC may have begun weakening a long time ago, starting around 1720. If that's the case, it would mean that the system is more sensitive than previously thought, responding to natural melting of ice sheets earlier than expected. It could also mean that the current AMOC is closer to a tipping point than we think, where the weakening becomes self-perpetuating and leads to a near-complete shutdown of these vital ocean currents. As global temperatures continue to rise, many climate models predict further weakening of the AMOC and potentially even a collapse this century. The Intergovernmental Panel on Climate Change estimates that there's up to a 10% chance of collapse before 2100. But new research suggests that this probability could be even higher. So what does this mean for us? The study adds further historical context to the debate, showing that even small changes in ocean circulation can have large regional consequences. A sustained movement of the Gulf Stream would lead to changing regional temperatures, rainfall patterns, and more extreme weather. It's a warning signal that any amount of slowing down could have serious effects, and a reminder that we need to take action to reduce our carbon footprint and mitigate the worst impacts of climate change. The question is, will we heed the warning, or will we continue to ignore the signs of a climate in crisis? The choice is ours. What do you think? Are we doing enough to address the climate emergency, or is it too little, too late? Share your thoughts in the comments below.